Alright, so I wanted to show you these factory I/O projects. You have to have a Windows machine, and I found before that when I'm running OBS and a virtual machine on this Mac Intel processor, it doesn't work very well. So what I'm using is remote desktop to my ARM processor Mac here, and that seems to be working pretty well. So I've got remote desktop protocol going into my virtual machine, which is running Windows 11 on ARM. And so I already installed Factory I/O, which is a good thing because it takes a while. Factory I/O is based on .NET, so first you have to install .NET, and then you have to install Factory. As part of the process, it'll install .NET, which is very slow, and it involves showing you a frozen progress bar for what seemed like about 5 minutes. So .NET is Microsoft's competitor with Java, and it is very slow. Anyway, it does work if you have patience, and so I've got Factory I/O installed. So once you've got it, then you can choose a scene to get started. You can, in principle, build your own factory setup, but we're just going to use the simplest, most basic scene. You go to scenes, you take number 1, the simplest case from A to B. Now, if your resolution is kind of small, if you have a small screen like I do in this virtual machine, then you can't, this box gets in the way. Now, this box is if you're going to add more conveyor belts or boxes or something to the scene, and I'm not gonna, so I hit this button up here, palette window, to hide that. Now I can see all I have is a conveyor belt, a box, and a sensor at the end. So notice when it's going to fall off the end and prevent that. So if I try to run this, it doesn't run at all because I have to have logic, which connect these components together. And so to put in the logic, you have to go to File Drivers, and then there are a wide selection of possible driving logic systems to use. And the first thing we're going to do is Control I/O, which is not a real one used in factories. It's a simulation used just for this piece of software, just to make simple flowcharts. You have to wait while it launches. This is the part where I got confused this morning. Thought it was broken, but it wasn't. You wait for it to start at the blazing speed of .NET. Okay, and when it starts, you have this window, which is different than that window, and you have to work in this window. So what you do is you expand tags, and now you can put the sensor here and the conveyor here. And all you want to do is when the sensor triggers, you want it to turn off the conveyor, so you just drag and drop a line connecting them. There, that's the logic. That is the program, such as it is. All right, and so now that you've done that, now if you go back to the main window, you have to go back here to get back to the window where you can see the factory back there, which you see through this. Now you can run it, and now it comes on, it runs to the end, and when it hits the sensor, it stops. So that's this thing running in all its glory. All right, now the fun part is going to be hacking into it, and that is the most exciting project, which is destroying a factory. So once you got this going, we're going to need to have the Open PLC editor. So I may have to install this on this virtual machine. Let me see. So go back to here. Now let me make this window a different size so the two will stay easily accessible at the same time. All right, so I'm going to close this for now. Discard changes. Close that. Don't save. All right, so let's see if I have Open PLC. I may not on this machine. I don't really know what I've got. Open PLC. I do not. All right, so it's here. I wonder if copy and paste works. Copy link address. Go to Firefox. Try and make this window movable. I have to make it wide enough that I can find some part of this I can grab. There we go. All right. Now, well, let's do it this way since I've got the projects here. Scroll is not working for some reason. All right. There we go. Open PLC editor for Windows. Okay. There it is. All right, good. All right. Yep. Yeah, she Zen Hacker also .NET. Yeah, .NET is pretty slow and irritating, but you know, a lot of people like it. It makes it easier to write your programs, I guess. Easier to put in graphical elements and such. Ah, there we are. So now I can install OpenPLC Editor. Okay, I got to run it anyway. It is not a commonly used program, so Microsoft's Smart Shield doesn't like it. Okay, just the defaults is all I want. And I'm pretty sure this is actually creating a simulated Linux environment. So, anyway. I'm settling for these versions of things I found that work. But I think that's why there's so much junk here. I think it's actually making a simulated Linux environment. Completed. All right, good. Let's see if I can run it. Try and get rid of this stuff. Doesn't really matter. Okay, OpenPLC. There it is. Okay, launch OpenPLC Editor. Okay. Then it's new. Create a new POU. Okay. Yeah, setting up Python virtual environment. Okay. Okay. Told me I should consider something and then shut down before I could consider it. So that's, here I am. All right, let's see if I make this a little bit smaller. All right. All right. So now new. Is that new? That's new. Okay, new. Create, give my thing a file, which is like demo. All right. That'll be fine. Oh, select folder. Choose an empty directory. Oh, I remember this. So I'll have to make a new directory, I think. What if I can do that here? Yep, new folder. Okay, factory demo. All right. Select that folder. There we go. Now, enter a POU name of main and a language of FBD. Okay, main. program language FBD, functional block diagram. Okay. Now, all right, I'm going to add variables here. So the green plus sign will add variables, and I think I have to make my window bigger to see it. There it is, the green plus sign. All right. So I hit that. Now I have a line to put variables in, and I make another one. So I have, okay, this is going to be eye sensor. Sensor, and it's a d-int, a local, local d-int. Okay, that's good. And no, I see. I have to change this to Boolean. I see. Base types Boolean. Okay, and this is the all-important thing that confused me for a while. You have to have exactly these names. These are the names that will connect to Factory I/O, the simulated factory. It's going to look for things with just these names, 100.0, IX 100.0. I'm trying to zoom in. There we are. Percent IX 100.0. That's right. Good. And so this one is Q conveyor. And Boolean. And percent QX 100.0. There. All right. Now drag the number 1 and drop it into lower. Drag number 2 down also. So number 1 goes down here into the design area. And number 2 goes next to it, sensor and conveyor. All right. So this is the, all right, just like we did before in that internal to OpenPLC. Now, you see they're both inputs now. We need one of them to be an output. So we need to double click this and change it to output. And say OK. Now you can see it's got the little line saying input. So now I can drag this line from one to the other, and there we are. Now I've recreated the same circuit we had before with Factory I/O in a more generalized language. So now we click the yellow down arrow to generate a runtime to put this in a real programmable logic controller. So this is what you call programming, dragging these things around until you got the circuit you want, and then you download the software to put in your programmable logic controller, and it is surprisingly big, slow job. Like they're going on for a while. It's finally done. All right. So now I save this thing. And okay, I'm going to call it OT121.st is the OpenPLC program. I guess it'll put that extension in by itself. ST. Okay. Save that. All right. Close this. Save your changes. That's fine. Okay, now I need to use a Debian machine. Now I'm going to put that on my Intel machine here because I think a headless server will run without encountering a huge slowdown due to the graphics from OBX. So this is Debian 11 running on Intel headless. Well, I could have used Debian 12. Yeah, I guess I'll stick with Debian 11. They're both pretty much the same. All right, so I've launched my Debian 11 machine. Now, I'm going to need this machine to reach that Windows machine, so I need to make this bridge networking to go directly to the wireless network that connects these two physical machines. So I've done that. Now I'm going to do sudo dhclient -v to get a new IP address. And good. I got 192.168.0.245. That's what I need. So now that I have that, I'm going to control this with SSH. So I can copy and paste. So I SSH Debian at 192.168.0.245. All right. All right, so now I'm in here. So let's see if I have Git. I do. I don't need to install that. Let's see if I already have this thing downloaded. OpenPL, looks like I do. So I can go into OpenPLC, all right, and then I can just run it with sudo start. There we are, and give it a password. Oh, it's already running. Once you install it, it seems to automatically run. So if I do sudo ss-pant, or more likely what's happened is I've just suspended the machine with it already running. It's already listening on 8080, so I think it's already available. So let's see if that's true. Let me just open up another window here and go to 192.168.0245.8080. Oh, I spelled this wrong. 192. There we are. And log in with OpenPLC and OpenPLC. Okay, good. All right, now I upload my program. So on the left side, I hit Programs, and then Browse and upload my file. So right now, the machine, it says it's running. I think I'm going to stop it. I don't think we're running while I'm doing this. Then I'm going to hit Programs, Upload. I need to select a file. Somehow I did the wrong thing. Oh, choose file. Okay. And here I have an old program I've already uploaded there. I don't quite know how to delete them. I wonder if you can delete the old ones. Right click. Yeah, how about remove? There we are. That's how you remove it. Good. So I'm going to remove these old ones. There we are. Now I'm ready to upload the new one I just made. So choose file. I want to go to my home folder. And then I made a thing today. All right, I seem to be in trouble. Let's see if I can figure out where I saved it. If I get a Finder window on my Mac, recently created. These didn't pick up recents well enough. Well, go home. All right, let's just see if I can search for it. It's SC121 or something. Let's see what I called it. OT121, okay. I'm getting lost here. There we are. OT121.st. There is one. It's in, that's the HTML file. That's not helping. See if this will work. All right, there are a couple of them, like this one. All right, this is not helping me. Oh, all right, when I'm hosed on a Windows machine, on a Linux machine, I can just get rid of all these stupid graphical things that don't work. All right. All right, so now it's that should do it. Nope. All right, I thought find would find everything. Is it find star? Oh, come on. How do you search? All right, I'm hopelessly lost here. Let's see if I can get anything to work. Google. I don't understand why I can't find a file on my Mac, but I really can't. All right, Google. How do I... where's Google? What is going on here? Google UK. All right. Google. How do I find a file on my Mac from the terminal? Because all the GUI stuff doesn't work. Using the find command. Find -name Okay, that's the fine thing. That's the hard way. I thought I had an easier way, but I'll settle for this garbage. So it's find dot dash name ot121.st dash exec. This is the part I can never remember, and I'm always trying to find ls minus ld curly braces backslash semicolon. There we go. Okay, at least it works. Now, when I was hacking into Linux boxes, just find would list every file name on the box. That's why I like the other way. Find pipe grep. But anyway, I may have to go make it again, or stop this video and replay the video to find out where I saved it. I thought I made a folder called factory demo or something. Maybe did I save it in? Maybe I saved it on my virtual machine. Oh, I'm using remote desktop. Did I create that on the PC? That might be what happened. I think I did. It's on this machine. Well, no wonder I'm not finding it. Okay, now I'm catching on. Okay, so here, now if I go home, once again, Microsoft has made everything hard and confusing. Whatever this home garbage is, it's not really my home. I need to get to the old-fashioned menu that works. C, users, Sam, and in here, I should be able to find the most recently created thing would be that folder. Apparently not. I was running this garbage on Windows, right? Yeah, so it's on this Windows virtual machine somewhere. Where did it hide it? Save it. I had to give it an empty folder, and I created an empty folder. Here it is, factory demo, but the sort by date doesn't work anymore on Windows because they've turned it into some kind of garbage instead. Okay, so there's the file I need. I wonder if I can drag and drop out of here. Well, this is a problem. What I can do is I can move it by SCP from here directly into Linux. Now that's what I'm going to do. Okay, so I go to my Linux, which is, I don't need this anymore. Exit. Nothing going to work. Okay. All right, so I do IPA. There's the IP address of my Linux machine, 192.168.0.245. So I can move that file from inside my PC. This is whatever the new command line thing is. I can't remember the name of the new command prompt on Windows. That's not the one. PowerShell, that's it. Okay, so I go into PowerShell. Now I need to find my way to this place, Sam Factory Demo. Good. Now if I do a dir, I see the file I want. So now I do SCP. Let's see if I can do help. SCP minus J destination. Oh, source target. That's all I need. So SCP. Okay, the source is .ot121. The target is Debian at 192.168.0.245 colon. That'll take me to the home of the Debian person, and then that'd be a good place enough to put it, I think. Let's see if this works. Yes. Debian. Okay, it's moved that file. It should now be in this Debian machine. If I do cd to go home, there it is, ot121.st. Now, actually, I think I wanted it on my Mac. So I think I'm going to have to do this again. I don't have any graphics on here. I can do it from the Mac terminal. I can pull it. Okay, let's get a Mac terminal. Quite a bit of hassle here, but let's do a Mac terminal. I should be able to use SCP into that Debian machine. So I should be able to do SCP. The source is Debian at 192.168.0245 colon slash ot121.st and put it here, there. But I got to spell 192 correctly. Okay. Okay, it didn't find it. ot121.st. Well, maybe I need to get rid of the slash. Yeah, okay, finally. Finally made it to my Mac, so now I can upload it from this graphical environment, which is somewhere like here. Okay, now I can finally upload it. That was pretty crazy, but that's a thing a lot of students get trouble with, just like me, moving stuff from one machine to another, especially when they're virtual and networked in irritating ways. There's the file. Now I can upload the file. Okay, it's timed me out just to irritate me here. So probably I'm going to have to do that again. Programs. Yep, I got to choose file. Upload. Okay. Now, when you're uploading it, I wonder if I care what name I give it. All right. ST121. 121. Okay. Compiling for Linux. So it was moving some kind of source code in whatever that language was, box something. Okay. Now I can go to the dashboard. Compilation finished successfully. All right. Now, okay, now we're going to launch Factory I/O and get the scene going. Okay, so that's here on Windows. All right. Scenes. Scene 1, okay. Now we're going to use the Modbus driver. File, driver, Modbus TCP/IP server. Okay. Now, that address 127.0.0.1.502 is not going to work, but it will go away. If I click configuration, we'll see a better address. There, 192.168.0.37, listing on 502. That's what we need. And in the bottom of this window, we're supposed to find two digital inputs. Okay, here's two digital inputs and one digital output, which is fine. Okay, good. So we can, top of the configuration, we can go back. And now it puts the right address and port number there, which is good. Okay, now we're going to connect these two things together. So here's the factory simulation. Now we got to go back to the OpenPLC window and go to slave devices. Okay. Now we add new device. Okay, and this is going to be Factory I/O. And it's going to be generic Modbus, TCP, slave ID is 1. Here I put in the IP address 192.168.0.245. Is it 245 for the Windows machine? It is 37, 192.168.0.37. All right. And the IP port is 502. All right. Now the discrete inputs, you have to fill all these in. It's annoying and you have to do it. So the inputs are 0, starting at 0 and going to 2. And the out coils are 0 going to 1. And all the rest is 0, but you have to fill it in or it won't let you do it. All right, now we save the device. And there it is. Good, now we start the PLC. Okay, it's running and showing logs waiting for client. Okay, hopefully making it. Listening on 44.8. Okay, waiting for new client seems to be normal. Okay, on the left we can hit monitoring. Oh, good. And now you see we have a sensor and a conveyor. Good, both showing true and a green icon. Good, so it's in contact with the machine. So now we're going to run the scene using the logic coming from this Linux machine. So let me get back to my Windows machine, which is here. Okay, now I go back and I run it. And now it works. It turns on the conveyor until it hits the sensor and then it stops. And if I look back at OpenPLC, now they're both off. The sensor, so that's good. So now I've got Modbus logic running over the network, controlling the factory. That's what I wanted. Okay. Now, there's flag to get here, but now we're going to use Metasploit. Let's see if I have Metasploit on my Linux box already. I think I probably do. So if I go to my Linux box, which is, let's get rid of this. I said, let's get rid of that. Okay. So let's see if I have MSF console. And I do. Good. Now we can attack the factory. All right. Surprisingly slow, perhaps. All right, there we go. It's moving anyway. And there they are, a bunch of Modbus attacks. So what we're going to do is scan it. We're going to use auxiliary scanner SCADA Modbus find unit ID. That's number 3. I think I can just use 3. Yeah. All right, then show options. All right. And so we need to tell it our hosts, the target, and then unit ID 2. I'm going to make it not search for 254, but only 10. So we set our hosts to the Windows machine, which is 192.168.037, and we set unit ID 2 to 10. So it'll try to find slaves up to 10, and then run. All right. And so it's looking. Okay, and so it finds station ID 1 is working and none of the rest are working. So that's a scan, which is correct. Now we can read from the slave. All right, and show options. And this will show us we need to have the Modbus data address, and the rest of these are our hosts. But I've already said I think our hosts from the past. So, we are going to have to fit it. So set data address. To 0. set number 5. Number is the number of coils to read, just like we've done before. 5 is a common number. Now we're going to set our hosts. I should have it up in my list here. Yeah, set our hosts to that address. And now set unit number 1. I think that's the slave address. And now run. And we get data. So here it reads the 5 values that are all 0 from the registers. So we'll be able to do a read over here. So now we're going to start the conveyor from the attacker. So we do info. And this module can not only read data, it can write. Write coil and write register is available. So we should be able to turn on the factory from here. So we're going to set action, write coil, set data to 1, and now exploit. But before I run it, I'm going to get the Windows machine visible so we can see if it works. And that's here. Okay, so there's the Windows machine. And the box is going to remain stopped because the running OpenPLC is keeping it turned off. See, right now there's a running program controlling it. So when I write it to turn on the conveyor, it doesn't turn on because the running program is keeping it stopped. So now there's plenty of ways to stop that. You could stop it with arc poisoning or other techniques if you had to control the network. What we're going to do is just manually stop it. So I go to here, there, and I'm going to stop the PLC. All right. I'm going to get back to where we were. All right, now we should just be able to repeat the exploit, and we should see it run without the PLC controlling it. So I want this to be visible. There we go. And I want the Linux terminal to be visible. There we go. And this can be smaller. All right, now if I run the exploit again, it turns it on and makes the box fall off the end. So that's the big thrill. I've taken over the control of that factory and made it do something it shouldn't be able to do. All right, that was the punchline. And like I say, that's essentially what this attack happened here. Israel did that to Iran, causing their factory to fail over the network. That's what I wanted to show you. All right, I'm going to stop this one.